So already you know that signal is signal is any I think in MATLAB session I have mentioned this. Okay, signal is signal is any physical quantity that change with respect to another physical quantity. Okay, another physical quantity. So we can have many example here. Okay, but most probably we are learning, I have told you that we are learning about electronics and communication, mainly electronics, electrical, and communication stuff. Okay, communication means the electronic communication. Okay, e-communication stuff. So mainly we deal with so physical quantity can be anything. So, okay, it can be a temperature, it can be a length. Okay, it can be time. Okay, it can be frequency, it can be a voltage. Okay, it can be a height, it can be a number of dogs in a city. Okay, I have told you this example there. Okay, and it can be number of Tamil person in a classroom. Okay, so there may be any physical quantity. Okay, which we are coming across in our environment. Okay, but in electronics, electrical communication stuff, we are not dealing with this temperature, most probably. Okay, not with the number of dogs. Okay, mainly we are focusing on, mainly we are dealing with voltages. Okay, voltages, current, and power. Okay, current and power. Okay, so these are the physical parameters. Okay, physical parameters we are mostly dealing with when we are learning this electronics, electrical, and communication stuff. Okay, and so this voltage, current, power, okay, can be changed according to the time. Okay, and in future you will learn that this can be changed according to the frequency. Okay, so sometimes you couldn't understand these things. Okay, so we will see it later. Okay, but this voltage, current, power, we can be changed according to the time. So you can understand this thing. Okay, it is very straightforward. Okay, but these things may be you couldn't understand, but later we will see what is that. Okay, so anyway, I'm trying to tell you that, okay, in electronics, electrical, and communication stuff, okay, signal is nothing but time varying voltage, current, or power. Okay, so this is a signal. Okay, so you know that if you can see the time varying signal, okay, using oscilloscope. Okay, oscilloscope in your there are many oscilloscope in your lab. In future you can use these things. Okay, and if you find the power or voltage or current changing with respect to frequency, there is another instrument that is we called spectrum analyzer. Spectrum analyzer. Okay, so we are mostly deal with the time varying stop voltage, current, or power. And sometimes we are dealing with frequency, frequency varying voltage, current, and powers. Okay. So normally time varying signal we called as a waveform. Okay. This is we called as a waveform, not a wave. Okay. It is a waveform. Okay. Actually, wave is another one. Okay. It is also depend on the space. Okay. This is not wave. Okay. This is not wave. Okay. Wave is a function of time and space, both the time and space. But signal time varying this voltage, current, or power, we called as a waveform. Okay. Okay. And frequency varying voltage, current, or power, we called as spectrum. Okay. Spectrum. Okay. So you no need to keep all these things in your mind. We will very often we will use this words. Okay. So automatically you can remember them. Okay. In future. Okay. So this waveform and spectrum we are hope to find, we are hope to process, and we are hope to calculate. We have to run many things in future. Okay. Okay. So let me take one example. Okay. One example. So so say we have a battery. Say we have a battery here. Okay. And if we connect this battery through a bulb, like this. Okay. So this is a bulb. Okay. So this is the most simplest circuits, no? Circuit we can found in electronics or electrical. Okay. This is the most simplest form of a circuit, no? Okay. So this is a battery. Okay. So this is a battery, and this is a bulb. Okay. Just a bulb. Okay. So say that if you this is a switch. Okay. This is a switch. So if you keep open this switch, okay, if you keep open this switch, okay, that means this so these are the cables. Okay. So this is battery and these are the cables. Okay. So this circuit is not complete, no? This circuit is not connected. So any current will not flow through this circuit. So this bulb will not light up, no? Okay. So this bulb will not turn on. Okay. So this is not turn on, it is in turn off. Okay. That means no current is going through this circuit. Okay. So if you close this switch, close this switch, then electrical circuit, so there is a complete electrical circuit, no? Okay. Okay. So the current will start to flow through this circuits. Then this bulb is turn on, no? Turn on. Okay. So if we keep this, okay, if we keep this, we know that when the current is flowing through this bulb, okay, this battery is draining, no? This battery is draining. That means voltage across this battery is reduced. This battery is draining. Battery bahina kiyan, this battery is draining. Okay. That means voltage of the battery is reducing, no? Is reducing. Okay. So you know that V is equal to IR. When V is reducing, if this R is constant, this I also will be reducing, no? So voltage is reducing, that means the current also reducing. Okay, reducing. Okay. So what happened? The what is we called it? The intensity of light of this bulb. Okay, intensity of light emitting from this bulb. It is also reducing, no? It is also getting low. Okay, so if we graph this, okay, so here you can have three values, no? Voltage, current, and the intensity of this bulb. Okay, or the intensity of light emitting from this bulb, or you can say that it is a power. No, it is a power dissipating from this bulb. Okay, dissipating from this bulb. Okay, so so with this circuit you can see that we have three variables, three parameters. One is voltage, one is current, and one is power. Okay, power dissipating through this bulb. Okay, one is power, let's say it is P. Okay, or it may be an intensity of light. Okay, okay, so you know that when this battery is draining, the intensity will be reducing, no? Battery බහිනකොට මෙයාගේ ආලෝකය එන්නේ අඩු වෙනවා නේ. හරි. current එක අඩු වෙනවා, ආලෝකය අඩු වෙනවා. Okay, so if we plot this with respect to time, if we plot, so we have voltage, we have current, let's say it is I, and also we have power. Okay, if we plot this, if you plot this voltage with respect to time, and if we can plot this current with respect to time, and we can plot this power respect to time. Okay, so you know that at the beginning the voltage is in high level, no? So if it is a 5-volt battery, so voltage is at 5 volt. Okay, then when the time is going, this voltage is reducing, no? Like this. Okay, I don't know the exact pattern. Okay, so anyway, the voltage is reducing, no? Like this, maybe. Okay, and also this current also will reducing, and this power also reducing. Okay, so these are signals, no? This is a voltage signal, this is a voltage signal, this is a current signal, this is a voltage signal, and this is a current signal, and this is power signal. Okay, so these are the waveform. In other words, we can say that this is a waveform for voltage. Okay, waveform, and this is a current waveform. Okay, and this is the power waveform. Okay, power waveform. Okay. So you can see that using this voltage signal or current signal or power signal, we can analyze this circuit completely, no? Okay, so if you have get any complex electronic circuit, okay, so it may be amplifier, okay, it may be a filter, it may be an analog digital converter, digital to analog converter. Okay, so it can be more complex one. Okay, that have several that integrate several this type of circuits. Okay, so but every circuits we can we can analyze, so we can understand using voltage, current, and power, no? Okay. So you can, I hope you can understand the importance of signal here. Okay. So this is very fundamental circuit. It has three signals, no? It has three signal. Using that three signal, we can analyze that totally, this signal, this circuit. Okay. So if you find more complex electronic circuit or electrical circuit, that one also classified, or that one also analyzed through this signals completely, no? So I think so I hope you can understand the importance of signal. Okay, importance of signal. Okay, so these signals are everywhere, no? These signals are everywhere. If you consider television, so there are many signals dealing with inside it, no? If you consider your mobile phone, okay, so it is completely depends on signal, no? It is completely working on signals. Okay, same as this TV is. If you consider radio, it is totally working on signals, no? So it is very important to learn about the signals. Okay, to emphasize that importance, I take this uh, example. Okay, so I hope you get it. Okay, so do you have any problem up to here? So do you have anything to clarify up to here? If you have any clarification, now you can ask. Okay, if I can't, if I am not able to answer the question, we can get the help from Dr. Udesh. Okay, because I am not I don't know the everything about the signals. Okay, my knowledge also very limited, your knowledge also very limited, so I hope you have some clarification, no? So if you have clarification, sometime I may be possible to help you. Okay, so you can ask if any clarification is there. Okay, so still we are not talking about system. Okay, now we are talking about signals. Okay, actually we are mainly focusing on signals, not with the systems. Okay, but later we will see something, what is a system, and what type of systems are there. These things we will discuss. Okay, but today mainly we are discussing about signals. Okay, so already you know what is a signals, and I hope you could understand what is the importance of the signals. Okay, okay, so we will see next classification of signal. Okay, classifications of signals. So so say if we consider people. Okay, so we are consider the human. Okay, humans. So how can we classify these humans? Can anyone tell? Can you classify this human? How can you classify this human? So actually there is no any hierarchy. There is no standard hierarchy. Okay, So based on different parameters, based on different parameters, based on different parameters, we can classify the human. Okay, for example, we can classify based on their qualities. Okay, based on their qualities or attitudes, based on their attitudes. Okay, so now we take we based on the attitudes of the human, we call them the human have good attitude and humans with bad attitudes. Okay, so we can classify this human into two parts: have good attitude and bad attitude. Okay, like this. Okay, so if you consider the nation, okay, if you consider the nation of or the country, okay, maybe a country of human, if you based on the country of the human they are living, okay, so you can classify them into several, no? These are Sri Lankan person, these are Indian person, these are Australian guys, England, like this. Okay. So based on their countries, we can classify the human, no, people. Okay. So maybe the based on their color. Okay. Based on their color, we can classify the human. Maybe a black person, white person, gray person, like this. Okay. So we can classify. Okay. So what can you understand here? If we are going to classify the people of the world, okay, we don't have a standard hierarchy, no? These people can be classified first into this, like this, then these can be classified this white, for example, first we classify the human, okay, peoples, okay, first we classify the few peoples according to the color, okay, this is white and black, okay, then this white people can be classified into good, bad, this black people also classified as good, bad, like this. You can't say, no? Okay, so there is no standard hierarchy. Okay, so same as signals. Okay, in signals also we don't have a standard hierarchy. Okay, can you understand what I'm trying to tell you? තේරුණාද කට්ටියට කියන්න කියපු එක? ඒ කියන්නේ අර ලෝකේ ඉන්න මිනිස්සු අපිට බෙදන්න බෑ වගේ හයරාචි එකකට, ස්ටෑන්ඩඩ් හයරාචි එකකට අපිට මේ ඉන්න සිග්නල්ස්, අපි මේ තියෙන සිග්නල්ස් උත් එහෙම ස්ටෑන්ඩඩ් හයරාචි එකක් නෑ බෙදන්න. හරි. Okay. So you can see that based on different parameters we can classify the peoples in the world. Okay, so as the signals. Okay, so signals also we can classify the signals, also we can classify it based on different parameters. Okay, different parameters. Okay, so that classification is changing. Okay, so these are very important. Okay, this classification of signals are very important. So those will come to your exam directly. So try to understand these things as much as possible at this time. Okay, so first I will say, okay, so I will get my example, that is the battery connected across the bulb. Okay, I will get the example. Okay, so here we have voltage, and here we have current, and here we have power emitting from the light. Okay, so you can see here, see here, we also can plot voltage according to the current, no? Voltage according to the current. And also we can plot power according to the voltage. Okay. And also we can plot power according to the current. Likewise. Okay. So we can get any value. Okay. This voltage according to the current, power according to the current, the power according to voltage. Okay, current according to voltage. Likewise. Okay, these are also signals. Okay, these are also signals, but in this course we are not mainly focusing on these things. We are only focusing on time changing signals. Okay, time change in these signals and frequency change in these signals. Okay, this time change in signals we are normally referred as time domain signal. Okay, time domain signal. These are we call time domain signal. Okay, that means the time. These are time domain signal. No, that means all the parameters are changing according to the time. Okay, in another words, time is the independent variable. Time domain signal means time is the independent variable. Independent variable. Okay, so this we call time domain signal. Okay, so can you remember that I told you that sometime we are seeing frequency change in signals. Okay, so what is the name for this? Can anyone take? Okay, these are time domain. So these are time domain signal. No, these are time domain signal. Time domain signal. Okay, so time domain signal can be analyzed through oscilloscope. Okay, so what are these signals? Can anyone tell? This is changing according to the frequency. This is frequency domain, no? So this is frequency domain signal. Frequency domain signal. Okay, so frequency domain signal you can analyze through spectrum analyzer. Okay, so this is time domain signal. This is frequency domain signal. So in our course, we are mainly dealing with time domain signals and frequency domain signals. Okay, so you can, that is why I take time here. The time domain signal, time is the independent variable. Okay, in frequency domain signal, frequency is the independent variable. Okay. So please try to remember these things. Okay, these are very important in future, will be very important in future. So mainly we are talking about time and frequency domain signal. Now we are at this point we are mainly focusing on time domain signal. Okay, time domain signal. That means these signals are changing according to the time. Okay, according to the time. Okay. So these are time domain signal. Now we are talking about time domain signal. Okay. Okay. So say that now you know that when we turn on the switch, if we have a switch here, if we turn on this switch, that means if we close this switch, this current will flow through this circuit, and this bulb is turning on. No, okay. So you you can see that battery is starting to drain. Okay, then this battery voltage is reducing. Okay, say, okay, say now we are plotting the voltage according to the time. Okay, according to the time. Okay, so I will do it like this. Okay, so to measure the voltage, what is the instrument you can use? Please tell someone what is the instrument you are using to measure the voltage or current. Please tell someone. If you want to measure a voltage, if you want to check a voltage of a battery of any two terminals, which instrument you are going to use? මොකක් පාවිච්චි කරලා අපිට voltage signals බලන්න, voltage current බලන්න පුළුවන්ද? Yeah, thank you, Ayas. Okay, it is a multimeter. No, using the multimeter, you can uh, you can uh, you can measure the voltage. So I connect a multimeter through this to this battery terminals. Okay, this is battery plus terminal. Okay, and this is the minus terminal. Make a plus agre, make a minus agre. So I will connect a multimeter. Okay, I will connect a multimeter from here to the plus end and minus end of the battery. Then I can measure the voltage through this multimeter. Okay. Okay. So as soon as this switch is closed, I measure the voltage here. Okay. So let's say it is 5 volt. Okay. Let's say it is 5 volt. I will get 5 volt. Okay. Then after 2 minutes, after 2 minutes, let's say 1 minute. Okay. Let's say after 1 minute, I will again measure this voltage. So sometimes this voltage can be, let's say it is 2 minutes or something. Okay. So this voltage can be reduced, no, up to another level. Okay. Let's say it is 4.8 volt. Okay. Then I will take another after 4 minutes. Okay. So again, this voltage will maybe reduce. Let's say it is 4.5. Okay. I will draw it again. Okay. So now I am measuring the voltage across this voltage, this battery voltage through this multimeter. Okay. Then I just mark it with respect to time. Okay. So let's say at the starting point, let's say it is 0. At 0, it is 5 volt. After 2 minutes, it is 4.8 volts. After 3 minutes, it is, let's say after 4 minutes, it is 4.5 volts. Sorry. After 6 minutes, it is 3 volt. Likewise, I am measuring. So maybe after 20 minutes, the voltage may be 0.5 volt or something. Okay. So that means the battery is almost drained. Okay. So if I graph this signal, if I graph this values with respect to time. Now time I get in minutes, no? And voltage I get from volt, okay, from volt. Now I am plotting this value, okay. So at zero, it is 5 volt, okay. At 2 minutes, it is 4.8, okay, like this. At 4 minutes, it is 4.5, like this. This value will be 4.5, okay. At 6 minutes, it will be 3 volt, okay. So at 10, it will be another sometime volt, okay. Maybe up to 20, it is almost 0, okay. So if I connect this value, I will get like this, okay. So you can see then, okay. So you can see then I get separate time value here. That is the important thing I want to tell you. I get separate time value here. First 0, then I will get 2 minutes, 4 minutes, 6 minutes, 10 minutes, 20 minutes. Okay. So I have like this and like this. So I will draw it clearly. Okay. So this is voltage. This is time. Okay. And this is 5 volt. Okay. And here it is 4.8, and here it is 4.5, okay, and here it is 3, okay, and up to 20 minutes, it will be maybe 0.5 or something, okay. We don't know, these are not exact value, okay. I just take example, okay. So it may be 0.5 volt, okay. So if I plot this value here, it is 5 volt I will have. Here it is 4.8 at 2 minutes. No? Here it is 4.5 at 4 minutes. Here it is 3 volt at 6 minutes. Okay. And we have another voltage value like this. No? Okay. So this may be 8 minutes. This may be 10 minutes. This may be 12. This may be 18. This may be 16, 18, 20 minutes. Okay, up to 20 minutes, I get some voltage value. Okay. So that means actually I get from 0 to 20. If I get 0 to 20, okay, if I get the voltage value, okay, if I measure the voltage value, if I measure the voltage value from 0 to 20, from 0 to 20, I will have 21 voltage value, no? 21 voltage value, 0, 1, 2, 3, 4, 5, 6. This is also 1 point, no? This 0 is also 1 point, okay? So up to 1, it is, no, I will get from 20 minutes, no? So then I will have 11, no? I will have 11 voltage value. Okay, so can you, I think you can understand it. If you have 0, then I will get with 2 minutes, 4 minutes, 6 minutes, 8 minutes, 10 minutes, 12 minutes. Okay, then after 14 minutes, then 16, 18, and 20. So let's count how many points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No? So 11 points, 11 voltage level I have measured. No, 11 voltage levels, 11 voltage point or value, voltage value, I have get 11 voltage values. Okay, from 0 to 20 minutes. I have measured it using the multimeter. Okay, So you can see that this voltage point can be counted, no? From 0 to 20 minutes, from 0 to 20 minutes, I have 11 voltage value. Okay. So we have some constant value here from 0 to 20 minutes. I have 11 value, only 11 value I have get. Okay. So this we call, okay, this type of signal we called discrete time signal. Okay. This type of signal we called discrete time signal. Okay. This type of signal we call discrete time signal. And why we call this discrete time? We get time. Okay, if we consider the time, okay, if we consider the time from 0 to 20 minutes, from 0 to 20 minutes, from 0 to 20 minutes, I have only 11 time values. 11 time values, no? 11 time values, and for these 11 time values I have corresponding 11 voltage values. Okay, so I have time values 11, no? 1 2 3 4, these are time values. 1 2 1 2 3 4 5 6 7 8 9 10 11. Okay, these are time value, these are time values, no? From 0 to 20, from 0 to 20 I have only 11 time values. Okay, this we called, we can count. Okay, so we the countable, for the countable things we use this discrete words. Okay, it is a matter of word. Okay, this type of things we call discrete. Okay, so this time is a variable actually. Okay, so at this time is a discrete variable. Okay, so we can say that at this point this time is a discrete variable. Okay, so let's say that if you want to add this voltage value, this 5, here it is 4.8, here it is 4.5, here it is 3 volt, maybe this is 2 volt. Okay, this is maybe 1.9, so this is maybe 1.8, 1.6, 1.5 maybe. Okay, so anyway you have some countable value, no? So if you want to add this value, simply you can get the summation, no? Simply you can add this value, no? You can add, no issue, no? You can add 5 plus 4.8 plus 4.5 plus 3 plus like this 0.5. So you can simply add this value. That means you can get the summation. So symbolically, we will use this sigma notation for summation. No? So you will get a summation. Okay, summation of volt from 0 to 20 minutes. This is the notation. No, this is the notation. I think sometime you may familiar with this notation. If not, please use the internet or try to understand. Actually, it is very simple. If you have any problem, you can just ask. Okay. Okay. So for this type of signal, we no need to do any integration. We can simply add the value. Okay. Okay. So these are discrete time signals. Okay. That means within some time duration, we have discrete time, countable value, discrete value. Okay, in other words, discrete variable. So this kind of signal, okay, we called as discrete time signal. Okay, so again I will tell it, if the time is a discrete variable, if the time is a discrete variable, okay, මේක කටපාඩම් කරගන්න ඕනේ, just you should have the idea only. Okay, okay, Okay. So if the time is discrete variable, that means, what is discrete variable means? Within, that means within two times value, within some time value, okay, time, what is called, within some time gap, maybe gap, okay, within some time gap, we have countable value. We have countable time values. We have countable time values. Okay. So we called it discrete variable, discrete time. Okay. So if the time is discrete variable, we call this discrete time signal. Okay. Okay. So let's say, so can you remember the first graph I have drawn? Okay. So that graph, practically we can get that graph, no? This kind of discrete graph we can get practically. This is practically we can get. Okay. This is very important if you can understand. Okay. Okay. So this is practically we can get. Okay. This is practically we can measure. Okay. But this is not the practically. So this is the measurable. Okay. We can say that this is a measurable. This is measurable. Measurable values. No, these are measurable value. We can measure. Okay. But practically how it happened? Okay. Practically, okay, this voltage, okay, voltage across the battery, okay, voltage, this voltage across the battery is reducing like this, no? From 0 to 20 minutes, it is reducing. No, this is 5 volt to 0, the battery is reducing. Okay. This is the practical. This is the practical situation. No, this is the practical situation. The voltage is reducing continuously. No, this is the practical system. No, the frequency, sorry, voltage is reducing continuously. No, please note this word. This voltage is, this is the practical things. No, voltage is reducing continuously. Okay. So here you can see that. Okay. But can we practically measure this? Okay. So maybe we will, practically this cannot be done. Okay. Practically we can't measure this. Okay. Practically we will have some discrete value. Okay. We should have some discrete value, and after getting the discrete value, we can just join them and we can plot this kind of graph. Okay. But practically we can't measure, we can't get this type of signal, this type of graph, continuous graph. No, did you guys understand that? Okay. To get the practical, like practically, if you want to measure this voltage practically, you have to measure infinite number of voltage. That is, we can't do. No. Okay. But actually this is happening. Okay. But we can't practically measure it. Okay. This is the practical situation. This is the actual situation that is happening. Okay. But we can't measure it like this. Okay. We can measure some discrete value. We can get some discrete value when just join that parts. Okay. So try to understand that one. Okay. If you couldn't completely understand this thing, it is okay. Okay. We will see it later. Okay. So anyway, so you can see that the voltage is continuously reducing from 0 to 20 minutes. The battery is totally drained. Okay, let's say. Okay, now you can see that we have discussed this earlier. Within 0 to 20 minutes, with 0 to 20 minutes, we can't count, no, this value, number of value, we can't count. Number of values we can't count with this time space, okay. But previously, okay, previously we can count the time value with from 0 to 20 minutes. With this time period, we can count the number of time values. Okay, it is a countable values. Okay, we called it discrete. Okay, but here you can't count. There should be infinite number of uh, time values, no, time values. So corresponding to this time value, there may be infinite number of voltage value. Okay, so this type of signal we call continuous time signal. Continuous time signal. Okay, this type of signal we call continuous time signal. Okay, so let's now see, if you want to add this voltage value up to this point, okay, you can't simply do this. No, you can't simply do this. You have to integrate this voltage value. That voltage value is changing according to the time, and you have to integrate it with respect to time from 0 to 20 minutes. No, okay, that is how you can sum all these values. Okay, you can't simply add them like we have done here. Okay, so here you can use the summation mark, okay, the sigma marks, but here you can't use the summation mark. You have to use the integration mark. Okay, you have to do the integration here, but for the discrete case, you can simply count the value. Okay, so if I summarize the things I have told you here, okay, I have summarized the things I have tell you here. A signal can be classified into two parts. Okay, one thing is continuous time signal. Okay, continuous time signal, and this is discrete time signal. Discrete time signal. Okay, so this is we call continuous time signal, and this is discrete time signal. Okay, so what is the parameter? We get the time variable, the nature of the time variable. Okay, here our parameter is the nature of time variable. Okay, this is the nature of time variable. Okay, so if the time is continuous variable, okay, variable, we called it continuous time signal. Okay, we called it continuous time signal. Okay, we called it continuous time signal. If the time has a continuous, time is a continuous variable, that means time has continuous values, we called it continuous time signal. Okay, so at this point, please try to get the idea. Okay, If the time is continuous variable, okay, we call this continuous time signal. Okay, and this is the, so in many cases, this is the actual situation, real world situation. This is the real world situation. Okay, this continuous time is a real world situation. Okay, and you have to always do the integration if you want to get some point. If you want to add some point, you have to do the integration. Okay, so this is a real world situation. Okay, please try to understand this. I will get another example also. Okay, this is a real world situation. Okay, but if you consider the discrete time value, okay, that means if the time is discrete variable, if the time is discrete variable, we called it discrete time signal. Okay, actually this is not the real world situation, but this is the measurable or implemented situation. We can say that this is a, let's take the measurement, the word measurable. Okay, this is the measurable situation. Okay, this is the measurable situation. Okay, so you can get, if you want to add some point, you can simply get the summation here. Okay, no need to do the integration. You can get the summation of all points. Okay, so you guys understand this classification. This is one classification. Okay, this classification is based on the time variable, nature of the time variable. If the time is continuous, we called it continuous time signal. If the time is discrete, we called it discrete time signal. Okay, okay. So I will tell another example. Okay, so say a person, okay, let's say a person, okay, this is the person, okay, is speaking to the microphone. Okay, so anyone can tell what is the microphone is doing? So this is the microphone. What is microphone is doing? Can anyone tell? Yeah, the microphone is converting, okay, microphone is converting our sound, okay, converting the sound, okay, converting the sound into electrical signal, electrical signal. Okay, so microphone is connecting. Yeah, yeah, Mohammed, thank you. Okay, signals analog to electronics. So yeah, yeah, okay, we will see. Okay, your answer is partially correct. Okay, but some mistake is there. Okay, the microphone is really do the conversion of sound into electrical signal. Okay, into electrical signal, and this electrical signal will be look like this. Okay, still we didn't talk about analog and digital signal. Okay, analog and digital signal, future we will learn. Okay, future we will learn. Okay, so you can see that it will be like this. Okay, this kind of signal we will get. Okay, at the output of the microphone. So it is a time with voltage. Okay, maybe a current or power, but we can consider it as a voltage. Okay, so you can see that this microphone is converted our sound into a voltage value. Okay, so you can see that we are talking. Okay, then this voltage will be changing according to the time. No, okay, so we will get this kind of signal at the output of the uh, microphone. Okay, so this is a continuous signal. No, so this is a continuous signal. That means if you consider any two time periods, okay, two time periods, within this time periods, there are infinite number of values. Okay, we can't count them. So we call this continuous time signal. So this is a continuous signal. Continuous signal. Okay. Now you want to, okay, now you want to store this in a RAM or something. Okay, you want to store this signal in a RAM or something. Okay, so I think you have idea about a RAM. Okay, RAM is a digital circuit, digital signal. Okay, the digital electronic device. Okay, so it has some memory banks, no, like this. Okay, okay. So you can see that now you have to store the voltage value, no, with voltage value in this memory bank. Okay, in this memory bank, and you can see that we have limited memory banks. No, we have limited memory banks. We have limited memory banks. Okay, so total voltage. So you can see that if you get 0 to 20 minutes, now you want to store the signal from 0 to 20 minutes. From 0 to 20 minutes, there are infinite number of voltage level. Okay, so we can't store the infinite number of voltage level, no, because we have some limitation on our memory. Okay, there may be 20 memory banks. Okay, that means we can only get 20 voltage values. Okay, we can only get 20 voltage value. So what we do is we can, okay, so up to 20 minutes, say this kind of signal we have 0 to 20 minutes. Okay, so we can't store all these value because there are an infinite number of uh, voltage value. We can't store all the voltage value here. Okay, because then we can get some countable values. No, we will get some after 20 minutes, 2 minutes, after, let's say, after 1 minute, after 2 minutes, after 3 minutes, after 4 minutes, after 6 minutes. Like this, you will get some voltage value. Okay, so you will have, so you will have, okay, so you will have, okay, from 0 to 20 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. So you will have some voltage values. No? That voltage value can be count. That means limited values are there, not infinite values. Though these value can be stored in the RAM. From first RAM, we will store this point, and this point we will store in this memory bank. This point will be store this memory bank, likewise. Okay, we will do that. Okay, so you can see that practically we will have continuous signals. Okay, and to process it, to store it, we can't do it in continuous. It is very hard to do it in continuous manner. We can convert it to a discrete signal, and then we can manipulate it. Okay, so that is the idea you should get. Okay, so that is one signal classification. So I'm trying to I'm trying to give you the idea how this type of signals are important in practicals. Okay, practical life. Okay, okay, okay. So we will go for another classification. Okay, so if anyone have any problem with this, you will have the note. Okay, I will send it later. Okay, this note is prepared by Dr. Udesh. Okay, not by me. These are Dr. Udesh notes. Okay, so you can see that here the signals definition is there. Okay, so this is now we are talking about continuous and discrete signal. Okay, so this is the continuous signal and discrete time signal we will have like this. Okay, so I hope you get this. Okay, this mathematical representation is still we not come to this point. Okay, we will see it later. Okay, and then so you can see that there are many type of signal. Okay, the signal is classified into many types based on different parameters. Okay, there is no any hierarchy. Okay, so I think another very important classification is there. Okay, that is we called with the periodicity. Okay, the based on signal periodicity. Okay, so we will see it in another classification. Okay, so you can see that first we have classified the signal based on the nature of the time, no, nature of time variable. Okay, variable. Okay, now we are going to classify we are going to classify signals with respect to another parameter. Okay, that is we call periodicity. Okay, so based on periodicity of the signals, okay, we can classify it based on two signals. Okay, we can classify it mainly into two signal. Okay, based on periodicity we can classify a signal into two category, that is periodic signal and non-periodic signal. Okay, non-periodic signal. Okay, so this periodicity means repetitive repetitiveness. We can say another word, repetitiveness. Okay, that means if the signal is repeating, we called it periodic signal. Okay, so this signal is repeating. If the signal is repeating, we call this periodic signal. Okay, and if the period is not repeating, we called it non-periodic signal. Okay, okay. Before going to this point, okay, can you remember that do you guys have sorry do you guys use the maybe yeah, I think you have done some lab, no? You should have done some labs in our laboratories, no? So have you guys used that oscilloscope, CRO, cathode ray oscilloscope? Can you remember? In our lab, mainly we have two oscilloscope. One is cathode ray oscilloscope. The other one is digital signal oscilloscope. Did you guys come across through this instrument, oscilloscope? Okay. DSO means digital storage oscilloscope, digital storage oscilloscope. This CRO means cathode ray oscilloscope. Cathode ray oscilloscope. So can you remember this? Did you use these two oscilloscopes? These two types of oscilloscope? Have you used? Okay. ඔකට පාවිච්චි කරලා නැද්ද මේ ඔසිලොස්කෝප් තාම ලැබ් වල? Yeah, you use CRO. That is the answer I want to get you. Okay. So using this CRO, what type of signal can you observe actually? Did you guys notice it? Okay. This CRO doesn't have any storage capacity, no? This CRO doesn't have any storage capacity. Okay. Capacity. Okay. So can you guys remember what type of signal this CRO can view? This CRO can view what type of signal? So normally I think you have seen some sine wave like this, okay, like this, using the CRO, no? Okay, maybe some square wave like this, okay, using a CRO, okay, and maybe some transient signal maybe like this, okay, so that may be a capacitance charging and discharging, okay, this kind of signal like this. This may be a capacitance charging and discharging curves. Capacitor is charging here and discharging here, okay. So I think you have seen this kind of signals, no, using oscilloscope, CRO oscilloscope. So when the signal is terminated, okay, as soon as the signal is terminated, we can't see anything in the CRO, no? Okay. That means you can see that if this signal is repeating like this, only if the signal is repeating, so you can see the signal is repeating, no? Here, this signal, this voltage value is again repeating here, no? So if I go, I will cut this, okay. So if I draw sine wave like this, okay. So you can see that here some voltage value is here, and that voltage value is repeating after some time, no? Again, that voltage value is repeating again after some time, no? So you can see that this voltage value is repeating, no? Same as other voltage value. This, if you use this point, that one also repeating after this time period, again it is repeating, no? Again after the same time period, again it is repeating, no? So you can see that using a CRO, you will see only the repetitive signal, repeating signal, okay. This repeating signal we called as periodic signal, okay. This repeating signal we called as periodic signal, okay. And if the signal is not periodic, that means signal is not repeating. That means after like this, Okay. So after this point, the signal is, we can't say it is stopping. Okay. So I will go like this. Okay. Say like this. The amplitude of the signal is reducing. Okay. Like this. Okay. Say now this point, if you get this point, this voltage and this voltage is different. No? So you can see that at any point, this voltage value will not exist. No? Maybe exist for 1 or 2 times. Okay. Maybe here that voltage level can be exist. Okay. But it is not repeating again and again. Okay. So this kind of non-repetitive signal, okay, that means not repetitive signal, non-repetitive signal, we called as non-periodic signal. Non-periodic signal. Okay. Non-periodic signal. So these two are another two types of signal, periodic and non-periodic. Okay. So we have to discuss some. So guys has did you guys understand this periodic and non-periodic concept? Any issue with that? Simply, the signal is repeating. We called it non-periodic signal. Okay, it should not be a sine wave. Okay, so maybe like this. Okay, so this point is repeating again and again like this. Okay, that is a repetitive signal. Okay, okay, it should not be a sine wave. Okay, or square wave, or maybe the charging and discharging curve of a capacitor. Okay, these are also signal. Okay, this is voltage with respect to time. Okay, it may be this kind of signal. Okay, it may be a, so if for example, if someone tell the same word the same word with the same intensity and same speed. Okay, with the same speed and with the same sound. Okay, with the same sound and with the same word. Okay, it also generate a repetitive signal at the output of this microphone. Okay, so that signal may be complex like this. Okay, but again it is repeating like this. Okay, again it is repeating like this. Okay. So that type of signals are also repeating signal. You can see that this voltage level is repeating here, 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 likewise, and this voltage may be repeating here, here, likewise. Okay, so these are periodic signal. Okay, so I hope you understood it. Okay, so we will see some properties of periodic signal. Okay, so we will see some periodic properties of periodic signal. Okay, properties of periodic signal. Okay, so let us have another 15 minutes. Okay, because we started at 3.15. Okay, so we will end at 5.15. Okay, is it okay? Do you have another lecture at 5 o'clock? Yeah. Okay, we will continue up to 5:15. Okay, so this is properties. Now we are discussing the properties of periodic signal. Okay, so let's take a sine wave, for example. Okay, like this. Okay, so you can see that. Okay, you can see that this time, after this time, okay, so this voltage value will be repeating again at this point, no? Okay, so if you get this time, let's say it is capital T, this time gap, okay, repeating time gap, okay, repeating time gap to the near point, okay, near point, okay. So again after T, capital T, that voltage point again repeating, okay. After T again, that point is repeating, okay. So if I get again after T time, okay, T duration, again that point is repeating, okay. So you can see that at fixed time duration, the signal is repeating, okay. For example, if you get this point, okay, after T time, after capital T time, this point also should be repeating, okay. This point also should be repeating after capital T time, okay. And after capital T time, this point again will be repeating, and after T time, this point also will be repeating, okay? So you can see that after T, okay, so this is a fixed value, okay, this is a fixed value. After this time duration, the signals values, the same signal value will get, no, same signal value, same value will get, will come again, okay. So this time we called as period, okay. This time we called as period of the signal, okay. This is we called as period of the signal. So you have to remember this. What is this T, capital T? We called it period of the signal. That means after that period, the signal is repeated. Signal, the value is repeating. We will get the same value. Okay. So if I, okay, now we are starting the mathematical representation here. Okay. So let's say this is the signal. Okay, so let's say this is T, this is time, no? Sorry, this is the time axis. Okay, this is the time axis. And let's say this may be a voltage, this may be a current, or this may be a power, anything. Okay, let's say this is X. Okay, so you can see that. Okay, so this X is a time varying signal, no? So you can denote it as xt. That means this x is changing according to the time. Okay, so this is independent variable, and this x is denoting the dependent variable. Okay, so I think you know this notation. Okay, you don't know this notation because you have done the calculus. Okay, so I think you are familiar. If you are not familiar, you can ask the help from me. Okay, and I think it is better to ask the help from your mathematics teacher. Okay, if you can't understand, just send a email. Okay, I can't understand this, please explain. Okay, because our duty is to teach you. Okay, so you can ask anything from us. If we don't know, the answer for your question, we can ask it from another person. Okay, then we can find the question, find the solution, and we can tell you. Okay, so what you have to do is asking the question always and clarify your doubts. Okay, that is very important. Okay, try to get the maximum benefits from your campus. Okay, you are paying some uh, money to your campus. Okay, so don't waste them. Try to get the maximum benefit of that. Okay, so you can ask any clarification from your teachers, from your lectures and others. Okay, and you can do, you can come to the campus and you can ask to do, you can request to do some labs, you can request to do some practicals in the laboratory. Okay, so likewise you can get the maximum benefit. Okay, from your campus. Okay, that is the thing you should do. Okay, so you can see that this x is a dependent variable and this t is a independent variable. So this is a notation. Okay, so this xt is denoting the value voltage, if this x is a voltage, it denotes some voltage value here. Okay, so for example, if this is the t1, if the t1 is here and the corresponding value, let's say it is x1, so we can say that x t1 is equal to x1. Okay, so this is a notation. Okay, so t1 means x at t1. Okay, so this is a fixed value. This t1 is a fixed value. It is a constant. Okay, so this notation represent the x value. Okay, this x variable value here. So here it is x1. Okay, but here this t is not a fixed value, it is a variable. Okay, so this is a general representation for this function, this total function. Okay, so this t can be any value, this t can be any time value. Okay, any time value. Okay, okay, okay. Now okay, now I will get another repeating signal. Okay, so it may be a signal like this. Okay, so I said that after t time, okay, after t time, I said I will, so I will say that this is x and this is t. Okay, so let's say the, so this is a repetitive signal. You can see it, no? The signal is repeating. Okay, so this is a repetitive signal. Repetitive signal. Okay, repetitive signal. So you can see that this signal is repeating. So you can see that this voltage will repeat after some time again, and that voltage again after repeating after some time. Okay, let's say this time is capital T. Okay, so this time is capital T. So what is this T? We called it a name, no? What is this T? This is the period, no? This is the period. We use that word. This is the period. It's period of the signal. Okay, we have mentioned it. So this is the period of the signal. So say the period of the signal is t. Okay, for the signal period is t. That means after t time, the signal will get the same value. Okay, so let's say this point, okay, let's say this point, is T1, okay. And what is this point? Can anyone tell what is this point? So if this time is T, okay, this is period T, what is this point? Please tell someone. If your answer is wrong, it is okay, okay, no issue. Just tell me what is that value. If this value is T1, what is this value? So this value is T1, and from here to here, it is another T value, no? That is the period. So after this period, the signal is repeating. Okay. So what is this point? This time point. Yeah, Mohammed, it is T2. Let's say it is T2. Okay. Thank you, Mohammed. Okay. It is, if it is T2. Okay. So you can write this T2 in terms of T1. Okay. So what is that value? T2 equal to what? You can you can you can write this T2 in terms of T1 and T. No, it is not. Yeah, Oshan has sent the answer. Mohammed, you have sent the answer, and thank you for sending the answer. Okay, thank you. But okay, anyway, you attempt to answer the question. Okay, that is very important. Okay, if the I don't care, the answer may be wrong or correct. Okay, it is okay, no issue. Okay, you can see that. I will write it again. Maybe you can't see it clearly. That is the problem I heard. Okay. Because I know that uh, after O level, you didn't do any maths subject, no? You are you have learned the technical subject only, technical things, not the mathematics, no? So maybe you have some mathematics issue, okay? So this is T and this is X, okay? So my signal is like this, okay? Maybe like this, okay? Like this. Sorry, maybe like this. Okay, so I get this point as T1. Okay, so I said that the period of the signal is capital T. Capital T is the period of the signal. Okay. So if I get another T duration from this T1 to here, okay, this voltage level will be again repeating here, no? Okay, so let's say this point is T2. Okay, so what is this duration? This duration is T. Okay, let's say this T1 is 2 millisecond and this T is 4 millisecond, for example. So T2 is nothing but 6 millisecond, no? So here it is 2 millisecond, and from here to here it is 4 millisecond. So 2 millisecond plus 4 millisecond means Here we have 6 milliseconds. Okay, so we can use this T1, T2 terms, okay, in the same manner. Okay, so this is T1. Okay, let's say this is T2, and we can say that T2 is equal to, this is T1, that is from here to here. Okay, and this T2 is from here to this duration, no, this duration is T2. So T2 is equal to this duration plus this duration. This duration is nothing but the capital T. Okay, so that is T1 plus capital T. Correct. So do you guys do you guys understand this? ඔකට තේරුණාද? තේරෙනවද කියන එක? So we can write it like this, no? This is, yeah. Thank you, Tisuni. Okay, thank you, Mohammed. So I hope you get it, no? So you can say that this T2 we can write in terms of T1 and capital T. So it will get like this. Okay. So what about this point? Let's say this is X1 and let's say this is X2. So you can see that X1 should be equal to X2, no? Correct? Because this voltage value, if this is a voltage signal, this voltage value is repeating here again. Okay, so that means this voltage value, we will get the same value again after here. No, okay, so you can say that this voltage value, this X1 and X2 is equal. Okay, so with that notation I have told previously, you can say that X at T1, that is nothing but this X1 point, is equal to X at T2. That is nothing but this point. Okay, X T2, this point, X2. Okay, so this is X1, the X value at T1. This is X2, the value of X at T2. Correct? XT1 is equal to ST2. Okay, so you can see that the T2 can be write as T1 plus T. Okay, so I can write like this: XT1 is equal to X T1 plus T. Correct? So did you understand this? So any problem with this equation? Okay. If you couldn't understand, because we will severally, so we will in future we will use this equation many times. Okay, and in your final examination also, this type of the question from this equation will come. Okay, so you can get some considerable marks for your final exam. Okay, so did you guys understand this equation, how we get this? This is very important, so I will tell it again. Okay, so you can see that this is a repetitive signal. Okay, that means the signal will repeat after some time. Okay, so repeating time, we called it as capital T. In other words, this is the period of the signal. This is the period of the signal. Okay, so this is the period of the signal. So for example, if we get any arbitrary point, any point, okay, let's say it is T1. Okay, so after T, that that after t, after capital T time, again, this point will be repeated. No, the value of this point will be repeating again here. So we will get the same value. Okay. So this T1, so this is the value at T1 time, and this is the value after capital T time. Okay. Okay. So you can see that this value should be equal. No. So this is the value at x value at T1. This is the x value at T1 plus T. That means after the period. Okay. After the period, you should have the same value if it is a periodic signal. So this xt1 is equal to xt1 plus T. Okay. So this T1 can be any time point. So generally we can write this xt is equal to xt plus T. Okay. So this is the condition for periodic signal. This is the condition for periodic signal. So we will stop here. Okay. So many things we have discussed related with the signal. Okay. So basically, actually within these 2 hours, okay, within these 2 hours, we have discussed. So you should be able to answer this question. Okay. What is a signal? Okay. What is a signal? This question you should be able to answer. Then why signals are more important? Why signals are very important? Okay. So we have discussed this because in every electronic circuit, so this is a signal means time varying voltage or time varying current or time varying power. That is a simple answer. Okay. So why signals are very important? Because in every electronic circuits, we have to deal with the signal. So signals are very important. Okay. And the third one, how we can classify signal. Classify signals. How we can classify signal? There is no standard classification. There is no standard hierarchy. We can classify it based on different parameters. Okay. So we have learned about 2 classification. One is the continuous time signals and discrete time signal. So you should be able to explain what is continuous time and what is discrete time signal. This is based on the nature of the time variable, nature of the time variable. And again, we have classify a signal, another form based on the repetitiveness, no? Repetitiveness or periodicity. That is periodic signal and non-periodic signal. So you should be able to answer what is continuous time signal, what is discrete time signal, and how you classify them to continuous time signal and discrete time signal. And here, what is a periodic signal, what is a non-periodic signal, how you classified it, how you classify the signal into periodic and non-periodic. That is based on the repetitiveness of the signal. Okay. And we have discussed the condition. Okay. So what is the condition for periodic signal? that is xt is equal to xt plus t. So these 1, 2, 3, 4, 5, 6. The 6 question you should be able to answer. Okay, that's all. Okay, so we will stop here. So I think you couldn't understand totally. Okay, so I hope the guys who gave the answers maybe understood it up to some level. Okay. So anyway, if you have any problem, you can just send me an email. Okay, I will upload this lecture. Okay, so my email address is nuan@sltc.ac.lk. I will send it. So this is my contact number. Okay. So I will send it to. Okay. And also I have a WhatsApp number that is 07186444612. Okay, so you can contact me through this. Okay, so I think you have get. Okay, okay, so if you have any problem, please you can email me, you can WhatsApp me. Okay, and it is better to email or WhatsApp. Okay, rather than calling. Okay, but you can call me, no issue. Okay. So if you guys have any problem, you can ask. Okay, so we will stop here, and thank you for joining the lecture today. Okay. Okay, and don't worry if you couldn't understand the things totally, that is okay. Okay, don't worry about that. But try to refer. I will send you the note. I will upload it to the LMS, this note and the lecture. So you can go through this note and go through this lecture and try to understand the things we have discussed. Okay, that's enough. Okay, okay, we will wind up. Thank you for being here.
Thank you, sir.
Thank you.